How can we find inverse function? And what is one-to-one function? Recall the information from the previous video. Inverse function has domain and range which are switched from original function f. Let's find the inverse function of y equals 2x plus 2. Don't forget that we have to switch domain x and range y. First, we have to write our original function, which is y equals 2x plus 2, and then switch x and y, which will give us x equals 2y plus 2. This one itself is already an inverse function of y equals 2x plus 2, but let's rewrite this function into form of y equals something something. After we do that, we get y equals 1 over 2x minus 1. And this one is our inverse function of f of x. Here's the graph of two functions and the table of value for each function, where g of x is an inverse of f of x. Let's check the property of inverse. Recall the information from our intro to inverse function video. If f of x and g of x are inverse to each other, then f of g of x and g of f of x are both equal to x. If we plug in our values into the functions, we can see that our functions satisfy the property of inverse functions. Like f of g of 4 is equal to 4, f of g of 6 is equal to 6, and so on. Let's try one more function, y equals x squared, or the quadratic function. Using the same method, we can find that the inverse function is y equals plus or minus square root of x. And here's the graph of how it looks like. But can we say this is a function? No, because it fails the vertical line test, which means it has two output from one input, and this one doesn't satisfy the doesn't satisfy that this is a function. In order to prevent this kind of situation, there are some restrictions of inverse function, which is one-to-one function. And the definition of one-to-one function is that a function is considered as one-to-one function if no two elements in the domain of f correspond to the same element in the range of f. And in order to have an inverse, a function must have an one-to-one function. This explanation is kind of unsophisticated, so I'll show you the diagram here. For the first one, each input has unique output, like 1 to A, 2 to B, 3 to D, 4 to C. We can say this function is an one-to-one function. However, for the second case, 3 and 4 are correspond to only one output. However, 1 and 2 has same output B. So this one is not an inverse one-to-one function. Let's check if x squared is a one-to-one function. I wrote some input and output values from the function, and let's let's draw an arrow between corresponding input and output. And this one will look like this. Do you think this is an one-to-one function? Of course no, because f of 1 and f of negative 1 are both 1, and f of 2 and f of negative 2 are both 4. We can conclude that f of x is not a one-to-one function. To check whether a function is one-to-one or not, we can also use a visual method. Let's follow the procedure and apply this into our quadratic equation. First, we draw vertical line and horizontal line. Here we have blue horizontal and red vertical line, and move them in same direction with direction of x and y axis. So this blue line, we can move this with same direction of y axis, and this red line, we can move this to same direction of x axis. And lastly, we have to check if one of these lines intersects with more than one point in any position. If there's no intersection with more than one point, this means the function is one-to-one function. If not, then the function is not a one-to-one function. Since we have two intersections with horizontal line here, the quadratic function is not a one-to-one function.